When pulling a disconnect on a cabinet, the safest position is on the right side of the cabinet, staying clear of the enclosure and operating the disconnect using your left hand. This approach aligns with NFPA 70 requirements for maintaining a safe approach distance, which means staying outside the potential arc flash zone, usually directly in front of the cabinet door. Standing on the right side offers better body clearance, keeping you away from any potential blast area, such as the enclosure opening. Using your left hand minimizes body exposure, reducing the likelihood of electrical contact with your dominant right hand. It is important to note that the idea of standing near the hinge side, with the cabinet door offering additional protection, is not correct. The cabinet door is not designed to withstand an arc flash and may shatter or become dislodged. Standing close to the hinge side actually increases your exposure by bringing you closer to the potential arc flash zone. For optimal safety, firstly, always follow the manufacturer's instructions. If the disconnect is on the right side of the cabinet, operate it from that side. Secondly, maintain a safe approach distance. For 480 volts to 2300 volt systems, this usually means staying at least 4 feet away from the potential arc flash zone. Thirdly, wear appropriate personal protective equipment, including flame-resistant clothing, gloves, and face protection. And fourthly, ensure that a qualified electrician or licensed professional performs the task. Several factors contribute to electrical safety in industrial environments. Firstly, understand the specific hazards associated with the equipment you are working on. This includes knowing the voltage levels, potential fault currents, and the arc flash hazard boundaries. Secondly, implement a comprehensive lockout-tagout procedure. This ensures that the equipment is energized and cannot be accidentally turned on while you are working on it. Thirdly, regularly inspect and maintain electrical equipment. This helps to identify and address potential problems before they lead to accidents. Fourthly, provide regular safety training to all employees who work with or around electrical equipment. This training should cover topics such as arc flash hazards, safe work practices, and the proper use of personal protective equipment. Personal protective equipment is crucial for electrical safety. Firstly, flame-resistant clothing protects your body from burns in the event of an arc flash. Secondly, gloves provide insulation from electrical shock. Thirdly, face shields or safety glasses protect your eyes and face from flying debris. And fourthly, hearing protection can help to prevent hearing loss from the loud noise of an arc flash. It is essential to select the appropriate PPE for the specific task you are performing. This includes considering the voltage level, potential fault current, and the arc flash hazard level. The arc flash hazard analysis determines the incident energy level and the required PPE category. Incident energy is the amount of energy that a worker could be exposed to during an arc flash event, measured in calories per square centimeter. PPE categories are based on the incident energy levels. Each category requires a specific level of protection. Category 1 PPE offers the lowest level of protection, while Category 4 PPE offers the highest. An arc flash is a dangerous electrical explosion that can occur when a fault current flows through the air. Arc flashes can cause severe burns, blindness, hearing loss, and even death. Several factors can contribute to arc flashes, including accidental contact with energized equipment, insulation failure, and corrosion. To prevent arc flashes, it is crucial to follow safe work practices, use appropriate PPE, and maintain electrical equipment properly. Safe work practices include energizing equipment before working on it, using insulated tools, and maintaining a safe distance from energized parts. Regular maintenance can help to identify and address potential problems before they lead to arc flashes. Grounding is another critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and energize the equipment. Grounding also helps to reduce the risk of electric shock by providing a low resistance path for current to flow back to the source. There are two main types of grounding: firstly, equipment grounding, and secondly, system grounding. Equipment grounding connects the metal parts of electrical equipment to ground. System grounding connects the neutral point of the electrical system to ground. Both equipment grounding and system grounding are essential for electrical safety. Electrical codes and standards, such as the National Electrical Code, or NEC, and NFPA 70E, provide detailed requirements for electrical safety. These codes and standards cover topics such as wiring methods, grounding, overcurrent protection, and safe work practices. It is crucial to follow these codes and standards to ensure electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, protect electrical equipment from damage caused by overcurrents. Overcurrents can be caused by short circuits, overloads, or ground faults. Circuit breakers and fuses are designed to trip or blow when an overcurrent occurs, which interrupts the flow of current and protects the equipment from damage. Circuit breakers can be reset after they trip, while fuses must be replaced after they blow. It is essential to select the appropriate overcurrent protection device for the specific application. This includes considering the voltage level, current rating, and interrupting rating. The interrupting rating is the maximum fault current that the device can safely interrupt. Electrical safety audits can help to identify potential hazards and ensure compliance with electrical codes and standards. Electrical safety audits should be conducted regularly by qualified personnel. The audit should cover all aspects of electrical safety, including wiring methods, grounding, overcurrent protection, safe work practices, and PPE. The audit report should identify any deficiencies and recommend corrective actions. Electrical safety training should be provided to all employees who work with or around electrical equipment. The training should cover topics such as arc flash hazards, safe work practices, the proper use of PPE, and lockout-tagout procedures. The training should be tailored to the specific tasks that the employees perform. Refresher training should be provided periodically to ensure that employees maintain their knowledge and skills. In addition to the NEC and NFPA 70E, other standards and guidelines provide information on electrical safety. These include the Institute of Electrical and Electronics Engineers, or IEE, standards, the Occupational Safety and Health Administration, or OSHA, regulations, and the American National Standards Institute, or ANSI, standards. It is important to be familiar with these standards and guidelines to ensure electrical safety. Electrical safety is a shared responsibility. Everyone who works with or around electrical equipment has a role to play in preventing accidents. By following safe work practices, using appropriate PPE, and maintaining electrical equipment properly, we can all help to create a safe working environment. When working with electrical systems, it's vital to understand key components and their roles. Firstly, conductors carry electrical current. They are typically made of copper or aluminum due to their conductivity. Secondly, insulators prevent current from flowing where it shouldn't. Materials like rubber and plastic are common insulators. Thirdly, transformers change voltage levels. Step-up transformers increase voltage, while step-down transformers decrease it. Fourthly, switchgear controls and protects electrical equipment. It includes circuit breakers, fuses, and switches. And fifthly, motors convert electrical energy into mechanical energy. They are used in a wide range of applications, from pumps to fans. Understanding these components and how they interact is crucial for safe and efficient operation. Proper grounding techniques are essential to minimize electrical hazards. Firstly, equipment grounding ensures that non-current carrying metal parts are connected to ground. This provides a path for fault current to flow back to the source. Secondly, system grounding connects the neutral point of the electrical system to ground. This helps stabilize voltage and reduce the risk of ground faults. Ground fault circuit interrupters, or GFCIs, are another critical safety device. They detect small imbalances in current and quickly trip the circuit, preventing electrical shock. GFCIs are commonly used in wet locations, such as bathrooms and kitchens. Arc flash studies are conducted to determine the potential hazards associated with arc flashes. The study involves analyzing the electrical system to determine the incident energy levels at various points. This information is then used to select the appropriate PPE and establish safe work practices. The arc flash study should be updated regularly to reflect any changes in the electrical system. Lockout-tagout procedures are designed to prevent accidental energization of equipment during maintenance or repair. The procedure involves isolating the equipment from all energy sources and applying locks and tags to prevent it from being turned on. Only authorized personnel should be allowed to perform lockout-tagout. The procedure should be clearly documented and followed consistently. Electrical hazards are not limited to arc flashes and electric shock. Other hazards include burns, explosions, and falls. Burns can be caused by contact with hot surfaces or electrical arcs. Explosions can be caused by flammable gases or vapors igniting. Falls can be caused by working at heights without proper fall protection. It's important to be aware of all potential hazards and take steps to prevent them. When selecting electrical equipment, it's important to consider the environmental conditions. For example, equipment used in wet locations should be rated for wet locations. Equipment used in hazardous locations should be rated for hazardous locations. The equipment should also be sized appropriately for the load it will be serving. Regular maintenance is crucial for ensuring the safe and reliable operation of electrical equipment. Maintenance should include inspecting, testing, and cleaning equipment. Any damaged or worn parts should be replaced promptly. A well-documented maintenance program can help to prevent electrical accidents and extend the life of the equipment. In addition to technical knowledge, good communication skills are essential for electrical safety. Workers should be able to communicate effectively with each other about potential hazards and safe work practices. Clear and concise communication can help to prevent misunderstandings and accidents. A strong safety culture is essential for promoting electrical safety. A safety culture is one in which safety is valued and prioritized by everyone in the organization. This includes management, supervisors, and workers. A strong safety culture can help to create a safe and healthy working environment. The use of technology can also improve electrical safety. For example, infrared cameras can be used to detect hotspots in electrical equipment. This can help to identify potential problems before they lead to failures or accidents. Remote monitoring systems can also be used to track the performance of electrical equipment and detect any anomalies. Firstly, regular inspections are essential to identify potential hazards. Secondly, promptly repair any damaged or worn components. Thirdly, ensure adequate ventilation to prevent overheating. Fourthly, keep work areas clean and free of obstructions. And fifthly, provide ongoing training to keep workers informed of best practices. Understanding the equipment's operating characteristics, such as voltage, current, and power ratings, is important. Voltage is the electrical potential difference between 2 points. Current is the flow of electrical charge. Power is the rate at which electrical energy is transferred. These parameters must be within safe limits. Insulation is critical for preventing electrical shock and short circuits. Thusly, inspect insulation regularly for damage or wear. Secondly, replace damaged insulation immediately. Thirdly, use appropriate insulation materials for the voltage and temperature. Fourthly, never overload circuits, as this can overheat insulation. Fifthly, ensure proper grounding to prevent insulation breakdown. Protective devices such as circuit breakers and fuses protect electrical circuits from overcurrents. Firstly, select the correct size and type of protective device for the circuit. Secondly, test protective devices regularly to ensure they are functioning properly. Thirdly, never bypass or tamper with protective devices. Fourthly, investigate and correct the cause of any overcurrent events. And fifthly, keep spare protective devices on hand for quick replacement. Safe work practices are crucial for preventing electrical accidents. Firstly, always energize equipment before working on it whenever possible. Secondly, use lockout-tagout procedures to prevent accidental energization. Thirdly, wear appropriate PPE, including insulated gloves, safety glasses, and flame-resistant clothing. Fourthly, maintain a safe distance from energized parts. And fifthly, never work alone on electrical equipment. Emergency procedures should be in place to handle electrical accidents. Firstly, know the location of emergency shut-off switches. Secondly, be trained in CPR and first aid. Thirdly, have a plan for evacuating the area in case of a fire or explosion. Fourthly, report all electrical accidents immediately. And fifthly, investigate the cause of the accident to prevent future occurrences. The NEC provides comprehensive guidelines for safe electrical installations. Firstly, follow all applicable NEC requirements when designing and installing electrical systems. Secondly, ensure that all electrical work is performed by qualified electricians. Thirdly, obtain necessary permits and inspections. Fourthly, keep accurate records of electrical installations. And fifthly, update electrical systems as needed to meet changing code requirements. Staying informed about electrical safety is an ongoing process. Firstly, attend regular safety training sessions. Secondly, read industry publications and standards. Thirdly, participate in safety committees and discussions. Fourthly, share safety information with colleagues. And fifthly, continuously seek ways to improve electrical safety practices. When diagnosing electrical problems, always use safe testing procedures. Firstly, verify that the equipment is de-energized before testing. Secondly, use appropriate test equipment, such as multimeters and voltage detectors. Thirdly, wear appropriate PPE. Fourthly, follow proper grounding procedures. And fifthly, interpret test results carefully and accurately. Remember to always verify zero energy. Before commencing any electrical work, the verification of a zero energy state is paramount. This process ensures that the equipment or circuit is completely de-energized, mitigating the risk of electric shock or arc flash. The steps include firstly, de-energizing the circuit at the source by switching off the relevant circuit breaker or disconnect switch. Secondly, locking out the disconnect switch to prevent accidental re-energization. Thirdly, using a calibrated voltage tester to verify that no voltage is present on the circuit. Fourthly, testing the voltage tester on a known live source before and after testing the circuit to ensure its functionality. And fifthly, grounding the circuit if required by the specific procedure. Following these steps meticulously guarantees a safe working environment and minimizes the potential for electrical incidents. When performing maintenance on electrical panels, several key steps should be followed. Firstly, de-energize the panel and verify zero energy. Secondly, inspect the panel for any signs of damage, such as corrosion, loose wires, or cracked insulation. Thirdly, tighten all connections to ensure good electrical contact. Fourthly, clean the panel interior to remove dust and debris. Fifthly, test all circuit breakers and fuses to ensure they are functioning properly. Sixthly, label all circuits clearly. And seventhly, document all maintenance activities. Effective communication is key to electrical safety. Firstly, use clear and concise language. Secondly, actively listen to others. Thirdly, ask questions to clarify understanding. Fourthly, provide feedback to ensure that the message has been received. And fifthly, document all communication related to electrical safety. Electrical diagrams are essential tools for understanding and working on electrical systems. Firstly, learn how to read and interpret electrical diagrams. Secondly, use diagrams to locate components and trace circuits. Thirdly, keep diagrams up to date. Fourthly, store diagrams in a safe and accessible location. And fifthly, use diagrams to troubleshoot electrical problems. A proactive approach to electrical safety is essential. Firstly, identify potential hazards before they cause accidents. Secondly, implement preventive measures to reduce the risk of accidents. Thirdly, continuously monitor the effectiveness of safety programs. Fourthly, learn from past accidents and incidents. And fifthly, promote a culture of safety throughout the organization. By consistently focusing on safety and following established guidelines, we can create a safer and more productive work environment. Remember, electrical safety is not just a set of rules, it is a mindset that must be embraced by everyone. Understanding and adhering to these principles will help protect you, your colleagues, and the equipment you work with. The safety data sheet contains critical information about hazardous materials. Firstly, always review the SDS before working with any hazardous material. Secondly, understand the hazards associated with the material. Thirdly, follow the recommended safety precautions. Fourthly, use appropriate PPE. And fifthly, know what to do in case of an emergency. The use of insulated tools is a fundamental safety practice when working on or near energized electrical equipment. These tools are specifically designed with non-conductive handles and coatings to prevent electrical current from flowing through the user's body in the event of accidental contact with a live conductor. Firstly, always inspect insulated tools before each use to ensure that the insulation is intact and free from damage. Secondly, use the correct tool for the job and never exceed the tool's voltage rating. Thirdly, keep insulated tools clean and dry, as moisture and contaminants can compromise their insulating properties. Fourthly, store insulated tools properly to prevent damage. And fifthly, replace insulated tools immediately if they show any signs of wear or damage. By consistently using and maintaining insulated tools, electrical workers can significantly reduce the risk of electric shock and arc flash injuries. Remember that insulated tools are only one component of a comprehensive electrical safety program and should be used in conjunction with other safety practices such as lockout tagout procedures and the use of appropriate personal protective equipment.